compound events. When looking at the likelihood that two or more events will occur, it's called a compounding event. And so when we're finding or probabilities, we find the probabilities and add them together. And then finding and probabilities, we find the probabilities and multiply them together. So let's look at the first example to see this. So example 1, a restaurant started to track how many of its customers would order alcoholic drinks, appetizers, and desserts outside of the happy hour times. They found out the following below. So 4 out of 10 customers would order alcoholic drinks, 5 out of 10 customers would order an appetizer before their dinner, and 1 out of 10 customers would order a dessert after their dinner. So what is the probability of a customer ordering an alcoholic drink and an appetizer before his or her dinner? So notice we have the and probability. So we know that we need to multiply the probabilities together. So let's go ahead and find the probabilities. So ordering an alcoholic drink, let's look at that. Well, it says 4 out of 10 customers will order alcoholic drinks. So we would write 4 out of 10. Now ordering an appetizer before his or her dinner, 5 out of 10 would order. So what we're going to do is multiply those together because it's an and probability. So we multiply what's on the top and we multiply what's on the bottom. So we get 4 times 5, well that's 20. 10 times 10 is equal to 100. And when we go ahead and reduce that, it's 1/5. So what's the probability of a customer ordering an alcoholic drink and an appetizer before his or her dinner? 1 out of 5, right? Or 1/5. Now let's go ahead and look at the second example. So what's the probability of a customer ordering an appetizer before his or her dinner or dessert after dinner? Well, notice that we have an or, so we're going to go ahead and add. So let's just go ahead and put the addition sign there. Now ordering an appetizer, well, we did this in the last one, and that's going to be 5 out of 10. Then ordering a dessert, well, that's just going to be right here, 1 out of 10. So we could put 1 out of 10 here. And then we go ahead and just add these two probabilities together, right? So 5 plus 1, right? We just add the numerators and we keep the denominator. So it's 6 out of 10, which can be reduced into 3 out of 5. Now let's go ahead and look at the second example. Example 2. An educational data analytics business has implemented a new system at a college to track the students in an online math course. The educational data analytics business found the following. So 3 out of 5 students would fully watch the online lectures. 1 out of 5 students would watch half of the lecture. 1 out of 5 students would not watch the lecture. 2 out of 7 students would attend TA office hours, and 1 out of 7 students would use the additional videos and questions. What is the probability of a student would fully watch the online lectures and attend TA office hours? So notice we have an and probability. That means we're going to go ahead and multiply the probabilities together. So we're going to go ahead and look for watching the full lecture. So that's the first one. That's 3 out of 5. Then we're looking for 10 TA office hours. Well, that's 2 out of 7. So we go ahead and multiply, right? We multiply what's on the top, and we multiply what's on the bottom. 3 times 2, well, that is 6. 5 times 7 is 35. So 6 out of 35 would be our solution for the probability of a student, right, to watch a lecture fully and attend TA office hours. So let's go ahead and look at the second one. So what's the probability of a student would watch half the lecture or would use the additional videos and questions? So notice we have an or. This means we're going to go ahead and add the probabilities together. So let's go ahead and do that. So we have watch half the lecture. Well, that's only 1 out of 5 students, right? And then would watch additional videos or questions for that probability. Well, that would be 1 out of 7. So notice we have 1/5 plus 1/7. We actually can't add these. So we're going to have to refresh right back to module 2 and get this to be the same denominator. So we'll just multiply the other fraction by the other denominator. So we just multiply the first one by 7/7. So what does that become? Well, 7/35 plus 1 times 5 is 5, 7 times 5 is 35. What do we get? Well, 7 plus 5 is 12/35, and that would be our solution.